Horsey Divers, welcome to Facebook Live. I am Nicole, I'm your host, and we have Chelsea, Miss OctoGirl over here. Everybody say hi to Chelsea. All right, if you are listening in, it is a beautiful day today here in South Florida. So if you are not in South Florida, where are you listening in from? And do you still have snow up where you guys might be? Because I do know that last week some of you guys were talking about how it was very cold and that you wish you were down here in South Florida. All righty, so as you know, Facebook Live, if you are enjoying this presentation and you have questions, you are welcome to go ahead and type into the comment section any question that you might have, and we will try and get that answered. And also, if you are enjoying the presentation, give us a thumbs up, give us a smiley face or a heart emoji to let us know that you are enjoying this presentation. If you don't watch all of it, that's okay. We actually record this and post it to our YouTube channel so you can watch it later for any reason. But you do want to hold out because we have some awesome raffle prizes tonight. Don't forget to register on the Eventbrite. So you go to www.force-e.com. Go to the event tab, drop down, find the event, register before 7 o'clock, and you will be put into our online raffle. And we've got some pretty cool stuff, you guys. So make sure that you watch until the end. You're going to get a lot of great information, and hopefully you'll be a winner tonight. So if you guys are here, say hello to Chelsea, Miss OctoGirl. Chelsea, what do you have to talk to us about tonight?
Hi, guys. Hi, Alex. I'm just reading the chat right now. All right. Are we ready to get started?
Yeah.
Share my screen. Right. All right. Can everyone see the presentation? Can you see it? All right. Looks like we're ready to go. All right, thanks everyone for joining. Like Nicole mentioned, with Florida Atlantic University, I'm a marine biologist focused on octopus behavior. And here I'm going to get started. If you haven't been, welcome. We're actually going to go on a dive to my study location. This is Blue Heron Bridge for Foster Park. Part of the Lake Lagoon, and it is located in Briareus, Florida. It's a beautiful day, crystal clear water. My first octopus. This octopus is out during the daytime. Foraging, you can see a fish pond behind it. We actually go to a night dive and see another octopus that is out foraging as well. And before we get into the research projects, I'd like to talk about the different species of octopus that you can see in South Florida. And so first up, we have the Atlantic Longarm Octopus. All species names will be in parentheses, so I'm going to stick to common names because they're a lot easier to say. So this is the first species that you saw in the video. This is the Longarm Octopus. This is a very small species. So for this animal, and so above the mantle you have the head and the eyes, and so in this animal you can see that the eyes definitely protrude up and kind of looks stalk-like. Here's the funnel or the siphon of the animal, and then its arms, and its arms are lined with hundreds of suckers. And so for this animal, being a relatively small animal, the mantle length is about 2 to 3 inches long. However, it gets its name, the long arm, because the arms are about 4 to 7 times the mantle length. And you can see here that this octopus actually wraps the arms around its body, or it can actually use them kind of like a tower, or I call this the tripod stands, to stand up nice and tall like a lookout tower. The second species that you saw in the video is the common octopus. And you can find this in the Lake Worth Lagoon or, of course, out on the Florida Reef. And this is a relatively large octopus. So we see a lot of juveniles in the Lake Worth Lagoon at Blue Heron Bridge. However, its mantle length can be 8 to 12 inches long. So right here where my mouse is. And the Atlantic longarm probably weighs a pound or less. This animal can actually weigh up to 11 pounds. So it can be a much larger animal than the Atlantic longarm. However, at Blue Heron Bridge, we do find juveniles, and they can be the same size as that smaller Atlantic longarm. You can see another difference in the arms right here. So the arms of the common octopus are 3 to 5 times its mantle length. So they're much shorter than the Atlantic longarm, and they're also thicker or more robust. Next up in Florida, we have the brown-striped octopus, and this looks very similar to the common octopus. However, there's some key differences or characteristics. So if you are a snorkeler or diver or just love going to the beach, you may see an octopus in the water, and you can use these different color patterns or characteristics to help you identify what species it is, because there are certain characteristics that only a certain species has, or a certain type of octopus. And so for the brown-striped octopus, we have that this kind of like a grainy structure. You can see along the mantle and the arms. So the common octopus doesn't have this, only in the brown-striped. And then this octopus is actually doing what we call a dematic display, a threat or startle display, maybe towards a potential predator or another octopus. And so in this display, you can see that the octopus puts on this brown stripe across its eye. We call that an eye bar. And also brown stripes, kind of longitudinal stripes along the arms. And so that's where it gets its common name, the brown-striped octopus, and how this can help you identify this species. Next up, the Caribbean reef octopus. So of course, like in the name, you can find this along the Florida reefs. Also, it's very common in places where it's structure and rocks. And the key characteristic to help identify this species is its blue-greenish iridescent. Very key characteristic that the other species don't have. And you can see this in the mantle right here, that bluish green, along the eyes, and also throughout the webbing. Also that red, whitish, splotchy color pattern along the animal is another characteristic. This animal comes out late at night, so if you're doing a night dive, you will probably see this animal. So I covered relatively medium to large size octopuses, and now we're going smaller to the smaller octopuses. And one of them is the Caribbean two-spot octopus. And of course, like the common name says, this octopus has 2 spots, one on each side below its eye. So if you count the arms, this is the second arm of the octopus on the right, the third arm. Usually this spot is between the second and third arm. One here has an iridescent blue ring in it, and then that's also what you'll see on the other side. So here's a second picture. You can see a blue, they call it a false eye spot right here on this side of the animal, and then you would also see it over here. So those are the only 2 false eye spots with blue rings on that. So sometimes people think that we have blue ringed octopus in Florida. We do not. They have up to 50 to 60 rings. This animal has only 2, so it's a Caribbean 2-spot octopus. Relatively small animal, about the size of the Atlantic longarm, with its mantle being about 3 inches long. However, the arms are much shorter, and you can see that this lives in kind of a rocky rubble habitat. Now we get even smaller to the Atlantic pygmy octopus. And so this octopus weighs less than a pound. You can find it in seagrass beds, rock rubble areas, or even living inside shells that you see that this one is on right here. And the main difference between this animal and the other octopuses I identified is that this one doesn't have very colorful color patterns. So they call it kind of a drab octopus, and you saw previously with the Caribbean reef and the common octopus, it had mottled color patterns, or it had blues, greens, reds, browns. With this animal, it has more of a uniform color pattern, so it could be uniform light, dark, shades of orange or brown. All right, and so now we're going back to the larger octopuses. And so the ones that I talked about previously are all benthic octopuses, meaning they live along the bottom. And now we're moving to the open ocean. So you'll see these in the open oceans along Florida. And this is the common octopus. You can also call it the violet blanket octopus. And so usually you see pictures of the big, beautiful blanket octopus right here. It's also known as the peacock of the sea, because this is part of the arm webbing. And this is only in the adult females. And so it's only the adult females that are the larger ones. So the large females can get to be about 3 feet long and weigh 22 pounds. And what they'll do is that this blanket is part of the arm webbing. It'll be curled up. But when they see a potential predator, they'll actually unfurl or uncurl their arm webbing and extend it, making them look much larger to predators. And this is actually one group of octopuses that shows sexual dimorphism. So usually when you look at an octopus, you can't tell if it's male or female, but that's not the case for the blanket octopuses. You see that the females are very large, and the male is shown right over here in the corner. The male is about 1 inch in size. And so you can definitely tell the difference between the male and the female and the blanket octopus, and also paper nautilus. So this is the greater paper nautilus. The female is shown right here. Females can only create that paper-like shell. The males do not. So the female greater paper nautilus is about 17 inches long in length, and the male is half an inch. So again, you have this size difference between the male and the female. Gets its common name because of its paper-like shell, like the nautilus. However, there are no chambers in the shell, and so it's just one open continuous shell, and the female actually uses the shell to anchor its eggs in and to hold its eggs in the shell until the eggs hatch. And so it's really cool with a lot of people being in the water and having communication with local divers, because scientists, we get to figure out what other animals are in the water. And this brings me to the Brazil reef octopus. And so this is Octopus insularis. It was commonly known about Brazil. Its northern range really hasn't been identified. However, it's looking through photos and talking with, local divers, I found that, wait a second, this is the Brazil reef octopus, and this photo was taken in Florida. So now we're figuring out the northern range of this animal that they thought maybe just was only in Brazil. And so how we know that this is the reef octopus from Brazil and not a common octopus is because of key characteristics, which I highlighted earlier, that only certain species of octopus have these characteristics. And one of them is right here. The underside or ventral side of the arms has this red and white color pattern. So this is a key characteristics for the Brazil reef octopus and not the common octopus. And also this eye bar right here across the eye. And so it was really cool to see that this may be a new octopus that we have in Florida, and another one that I call the mystery octopus, because I'm still figuring out what species of octopus this is. This photo was actually taken at Blue Heron Bridge. And at first, when I looked at it and figured, oh, this octopus is in structure, it must be a common octopus. And then I looked a little bit closer and I saw, wait a second, it has this red and white pattern like the Brazil octopus. And so I was like, all right, well then this is Octopus insularis. I kept going back to this octopus, photographing it for over a month, and I noticed that it also had a false eye spot, which is not in the Brazil reef octopus. And so now we're thinking that this is a different octopus, Octopus hanganda, that's usually found throughout the Caribbean, specifically in Mexico. And so I'm chatting with other scientists from these areas and sending these photos off to see if we can get an ID on this animal, and that may actually add to the number of octopuses that you can see in Florida. And so that is a brief overview and a quick octopus ID if you're out snorkeling or scuba diving to help you identify what species you may be seeing. But the main focus of my research is on two species of octopus, the common octopus on the left, the Atlantic longarm octopus on the right. And that's because these two species are in high abundance at the Blue Heron Bridge, the Lake Worth Lagoon. So the big research question is, how can there be so many octopuses there and they don't compete for resources? So looking at octopus coexistence and how we have this increase in octopus diversity in this Lake Worth Lagoon. And so that's a really big question to answer. How do two species of octopus coexist? So scientists like to break this up into specific questions so we can tackle this big overarching question. So first we need to figure out what are the different resources that each species uses. This could be where they live, so their spatial distribution at Blue Heron Bridge. Are they here year-round at Blue Heron Bridge? Are they coming and going? It's really close to the Palm Beach Inlet. What do their homes look like? So are they using these different types of structure like rock rubble? Are they using sand? When are they active? So looking at their activity times when they're leaving their home, or what I'll call the den, for food. So are they active at different times of the day to avoid each other? And then next, what do they eat? So are they competing for the same food source, or have they partitioned that? And are they eating different things? And how are they eating this? So looking at the behavior that is used to capture this food. And so I like to call myself a field biologist because I absolutely love field work. And so luckily I spent a lot of time diving at the Blue Heron Bridge. And this is a perfect study site for a scientist studying octopuses. If you haven't been here before, a quick description of the Blue Heron Bridge Phil Foster Park is it's a park open to everyone, open to the public. And what you can do is you park inside Phil Foster Park. You can load up all your dive gear. Once you're set, you just walk a short distance along the beach and then into the water. And so it's a shallow dive. I'd say average depth is around 10 feet. You will get a deeper depth along each side of the bridge. So the west bridge, you have an average depth probably around 15, 16 feet. And over here on the east side of the bridge, the deepest depth is around 21 to 22 feet. So since it's very shallow, I have a long time underwater. So my dives for research are usually 2 to 3 hours long. So that allows me a lot of time to look for animals that have excellent camouflage and are really hard to find. And so I'm also able to dive throughout the week, throughout the year. And so this allows me to answer this question, of how do octopuses coexist? And so you can see me up in the corner right here with all my dive gear. And so what I'll do is I'll get in the water with all my gear and I'll just swim north-south paths searching for octopus. And so once I find an octopus in its den, since it's shallow, again, perfect scenario for my research, since it's shallow, I can ascend to my dive float where I have a Garmin GPS device. I hit the waypoint and that records the coordinates that this octopus den is located at. And basically, I'll just do that over and over. As soon as I find an octopus, I'll ascend to my dive float and record the octopus location. So doing this over time, you'll see highlighted in green are all the marks for the common octopus. And then highlighted in pink or magenta are all the points where I found the Atlantic longarm octopus. And here's a still shot right here. So I did this for 3 years, spent a lot of time underwater, and we see that the octopuses are underwater neighbors. Yes, there are some distributed through the south area right here. However, there's more octopuses of each species along the southwest area of my study site, and there are more octopuses on the southeast area of my study site. So I'd like to say that they are underwater neighbors. They're living really close to each other. And so remember, I dove year-round for 3 years. So then I wanted to take all of those data points and actually break them up into seasons to see if octopuses are here year-round, or if there's a peak octopus season, and if they are more abundant during a certain time. So I broke that number of octopus up into seasons: winter, spring, summer, and fall. And we see that there is a seasonal difference. We see that there's not many octopuses at Blue Heron Bridge during the winter. It peaks in spring, it starts to drop in the summer, and then it declines with very few octopuses that I found in dives in the fall. And sometimes on my dives, I would find 0 octopuses during the fall and sometimes in the winter months. So I like to term octopus season during the springtime. So if you're wondering when a good time to see octopuses are in South Florida at Blue Heron Bridge, that time is coming up. Best time is spring, March, April, and May. And so we figured out the 2 research questions of these octopuses being underwater neighbors. They're here at the same time in high numbers during the springtime. So the next question is, well, how are they living so close to each other, or do they have different habitats? And so to answer that question, I used what's called a quadrat. So basically it's a PVC pipe of a known area, this square right here. And what I'll do is, there's a tiny picture of the square. There's actually an octopus right here. So it's kind of an aerial shot or a bird's eye view of this picture along the left. I would place this quadrat over the octopus's home, the den habitat, and then I would take a photo. I would then take 8 more photos around the octopus's den, and I would term that the surrounding habitat. And so I did this 20 times for the common octopus, 20 times for the Atlantic longarm octopus. And so the not so fun part is putting all of these photos into a software system that overlays random points, and shown here. So these are 50 random points shown by red dots right here. Wherever that point lands on, I code for if that landed on sand, rock, rubble, or algae. And so I did that for all the points. And so that's 810 photos and over 40,000 points, but the results were clear. And we see that these 2 octopuses, although they're living very close to each other, they have different habitats. And so the common octopus will make its den out of structure. So you can see on the left, this structure can be hard bottoms such as rocks, shells, rubble. If you've dove the bridge before, you might have found these small animals in glass bottles or cement blocks. And then the Atlantic longarm is a sand-dwelling species. As you can see here, this animal is actually completely inside of a hole that it can make with its really long arms. And peeking out of that hole are the eyes right here. So although they live close to each other, they're using these different substrates to help them coexist in this area. And so what's really cool about octopuses is that they have a lot of information that they have to take in from the environment. They're benthic animals. And so to do this and to figure out the best suitable habitat, they're using their eyes. And so one thing that you may notice when looking for an octopus is their conspicuous eyes that kind of stand up, and they're really, really large. And so octopuses have about 20 million photoreceptors in their eyes. So they have excellent vision on the level of fish and birds. And what you may also notice is that their pupils are a little bit different. They actually have horizontal pupils. So since their eyes are positioned on the side of their heads and they have these horizontal pupils, that actually gives the octopus kind of a panoramic view of its environment along the ground. So it can look and see where the best or where the most suitable habitat is for them to select and make their home. So not only do they need their vision when they're moving through their environment, they also need to make sure that they have their balance and they're oriented correctly. So they're usually not moving across a flat terrain. It's usually rock rubble or coral reefs. And so they have balance organs called statocysts. And you can think of this as very similar to our inner ear that helps with orientation and balance. So very important, these different senses that the octopuses use to select their habitat. But not only that, their arms, all 8 of them, are coming in contact with the habitat. And as you can see, their arms are aligned with about 200 suckers. And so what's really cool about the octopus arms and their suckers is that they can actually discriminate between the size of an object, the shape, and even the roughness. So they can figure out if an object is smooth versus how rough it is. And so all of this is important information for the octopus to take in when it's selecting a habitat, and also, well, you'll see later, also for selecting a prey.
Look at this.
And so just to kind of wrap that up, remember those 2 pictures that we saw, and I keep saying that they're underwater neighbors. And remember that map that both species lived on the west side of the bridge and the east side of the bridge, but they lived in different habitats. The common in rock and rubble, the Atlantic longarm in sand. And so they're able to do this because Blue Heron Bridge has a very patchy environment. And this is just a representation of the benthic or the bottom environment that Blue Heron Bridge has. Out in the front is the sandy area. Along the west side, you have patches of rock, rubble, and sand. And also you have this patchiness on the east side. So this patchy environment is very important for allowing these 2 species to be underwater neighbors. But that's not the full story. So I'll continue on answering these research questions. Next, asking when's for dinner. When is dinner time? When are they coming out to feed and find their prey items? And so it's very important in science to make sure that you answer the question fully. So I cannot say that an octopus is active during the daytime or it's active, mostly during the nighttime, unless I know what the octopus is doing for all 24 hours of the day. Now, I don't know about you, but I like my sleep, and I do not want to be out diving. Although I do love diving, I don't want to be out diving at 2 or 3 a.m. in the morning. So we came up with a 24-hour monitoring gadget called the Octopus Monitoring Gadget, or the OMG. And what this is, it's a GoPro camera with a external battery and a light for nighttime footage, and a very large memory card. And so usually GoPros only last 2 hours. We have that external battery to allow the camera or the GoPro to last for at least 24 hours. And after we seal this up, we put weights on it to make sure that it stays in place, and also an anchor to make sure it stays in place as well. So here on the right side of the screen, you can see the Octopus Monitoring Gadget displayed. And of course, you've got to have an octopus. And so the reason for the red light is because octopuses are insensitive to red light. And what they have is they have what are known as rhabdomeric photoreceptors. And so what the heck does that mean? And so it's very different. It's different from what we have. Octopuses do not have rods and cones. Those are the photoreceptors we have. They have what are known as rhabdomeric photoreceptors, and other mollusks have those, and also arthropods. And something to know about that is that they only have one visual pigment, which means most octopuses are colorblind. And so you have to have at least 2 visual pigments and usually more to see color. And so they only have 1 visual pigment known as rhodopsin. And this visual pigment absorbs at the wavelength of around 470 to 475 nanometers, the shorter wavelengths. So when I say they're insensitive to red light, because red light is a longer wavelength. So that's why we use red light when looking at nighttime footage, because the octopuses aren't bothered by it. It doesn't change their natural foraging behaviors. And that's the question I'm really interested in. When are they leaving their den to forage and feed under natural behaviors? So it's very important to understand an animal when you're setting up your experiments for science. And so this is actually the first footage from the 24-hour octopus monitoring gadget. There's my dive buddy, and there's actually an octopus inside of that pipe. Fast forward a little bit, and you can see this octopus underwater shortly after midnight, coming out to forage and feed. If you look closely, you'll see that the arms are kind of spread out along the bottom. That's called speculative bottom hunting or searching, when they're kind of just touching and tasting the environment, seeing if there's any food there. And then you can also see the arm kind of go underneath the webbing towards the middle of its body where its mouth is located. And that's how I know, okay, this octopus is foraging for food. Goes back to its den, and then it actually leaves again shortly after midnight. Fast forward the video. Guys, I won't make you watch 72 minutes of video, and you can see that the octopus returns to its den. All right, so I deployed the OMG several times for the common octopus, several times for the longarm octopus, and I actually reviewed over 1,000 hours of octopus video, but it was well worth it because the results were clear. We see that the common octopus comes out late at night to forage. Peak foraging time is around 10 p.m. And for the Atlantic longarm octopus, it forages during the daytime, peak time being around 12 or 1 p.m. And so we see that they're underwater neighbors, but they come out at different times of the day to probably avoid running into each other. Next up, I want to figure out, are they eating the same thing, or are they eating different things? So what's for dinner? So one of the most common methods to figure out what an octopus diet is collecting their prey remains that they usually discard around their den. So you can see that that's my hand in the video, and I moved these prey remains or shells away from the octopus's den, and I'm lining them up to photograph. Octopus wasn't a big fan of that since I moved the shells away from the opening. Octopus said, well, if you're gonna look at my shells, I'm gonna look at your camera. So that's fine. So it was a win-win situation. The octopus got to check out the camera. I got to take photos of the shells, and then I left the shells there for the octopus to use around its den. And so that is the most common method that has been used for to look at octopus diets. However, not all octopuses leave their prey remains around their den. And this was the case for the Atlantic longarm. Again, this is a sand-dwelling octopus, so there's nothing around its den. And if it were to leave shells around its den, it may actually attract predators, and the predator may see that there is an animal living there. And so it definitely was harder to get information from this sand-dwelling octopus. And I actually had to follow it on foraging events to get this information. And so these octopuses could be out foraging from 1 to 2 hours. I would follow them. And so I was able to get information about the Atlantic longarm. And see, there's a crab right there. So I would review the video very carefully to see if I could capture what these animals were eating. It's never been reported, the diet of this Atlantic longarm, so this was the first study to do that. And I can see why, because it's very difficult to figure out what they eat. And so I would follow these animals during foraging events. If they would spit out a prey item, I would quickly try to catch that prey item, put it in a baggie, and take it back to the lab to ID. And also what's cool to note is that these animals eat on the run. And so you notice that this animal consumed one crab, but didn't stop. It actually holds it in its arms and actually goes to consume another crab. And so just a quick overview of all the information that I gathered from collecting prey remains, mostly shells or exoskeletons, is that you can see I collected 139 prey remains, but most of those were from the common octopus because it littered or scattered prey remains around its den. And so first starting with the common octopus, it consumed mostly bivalves, different clams, mussels, an oyster. And so the popular item for this animal to eat was the species on the left called Chione elevata, a bivalve that lives pretty shallow in the sand. Next up were gastropods. And so this species consumed different types of conch right here. After that, crustaceans. So consume different types of crab. We have rough box crab, a shamefaced crab, and actually a mantis shrimp. So there's different types of species of mantis shrimp at Blue Heron Bridge, and this is the smaller of the mantis shrimp. However, I think it's still pretty cool that an octopus can eat and tackle a mantis shrimp because they're pretty tough animals. And then it also collected claws from a juvenile stone crab. We see that it's different results for the long arm. This animal only consumed one bivalve. So over probably the 5 to 6 years that I've been studying these two animals, I've only seen the Atlantic longarm eat 2 bivalves. And so one of them was just recently. It wasn't part of this study. And so I only have one bivalve here for the Atlantic longarm. 0 gastropods. And this animal I mostly caught on the run consuming crustaceans, very similar species that we saw in the common octopus, shamefaced crabs, rough box crabs, some really small unidentified crabs, a mantis shrimp, and then a purple-legged swimming crab. And this was great for this octopus because you can see it has a really large crab, but also this crab has eggs, so that's a pretty good meal for that octopus. All right, and so just like selecting a habitat, an octopus uses multiple senses to figure out where its food is and to how to hold on to that food item, because crabs usually they want to run away really fast. So how do you tackle a crab? And so first, they may use both vision and tactile information from their arms, or one or the other. So octopuses actually have monocular vision since their eyes are positioned on the side of their heads. They have monocular vision, really no binocular vision, and what's been suggested is that they actually have a preferred eye to select their prey. There isn't much research yet to back that. However, that is one idea, that they do have a preferred eye for selecting that prey item or zoning in on it. So they're using vision. Of course, the orientation with the staticist, you got to make sure that you have your orientation and your balance while chasing your prey item, such as a crab. And then smell. Octopuses don't have noses. However, they still can smell the chemicals that are in the water. And they have a bunch of dimples on their body. And most of those dimples are along their mantle. And those dimples can actually pick up or smell, the chemicals in the water. So they can smell with their skin, and they can also taste with their skin or taste with their arms. So not only can they touch and figure out if this is smooth, rough, and the size of this item, but they can actually taste if it's actually something that they want to eat. And so octopuses have, it's around 10,000 chemoreceptors on each sucker. And so I'm going to do a little math real quick. And so think about 10,000 chemoreceptors on one sucker. They have 200 suckers on each arm. They have 8 arms. So that means the octopus has 16 million chemoreceptors. So these chemoreceptors taking in all that information of how its environment tastes. So just to give you an idea of our taste and thinking about the chemoreceptors or our taste buds, basically octopuses taste 10 or 20 times more than what we do on our tongue. So if you can only imagine all that information and all that taste or sensation they're getting by using their arms in the environment. So after they actually get that prey item and wrap around it with their arms, and so their arms are really, really strong, and of course their suckers, the suctioning to that bivalve or maybe that crab. After they hold on to that animal, they can either crack or crush the exoskeleton of a crab, or they may be able to crack or crush a very thin shell. And how they're able to do that is by their different mouth parts. So as you can see in this picture here, or shown by this diagram, the octopus has a beak. And so that's what's used to kind of crack or crush items or to hold on to a food item. It's very similar to a bird beak. If they can break that item open, that crab or that bivalve with the beak, they can then start to chew their food. And how they shred or chew their food is by using what's called the radula. So it's kind of like a ribbon-like tongue located behind the beak. And on this ribbon tongue are these rows of teeth. And so when it extends this ribbon, the teeth kind of pop up and they start to shred the crab meat. And so that's basically the octopus chewing its food into really, really tiny pieces. However, they have another tactic that they use if the shell's too thick or they can't break open the animal, or if they want to paralyze the animal. And so what they'll do is they'll hold on to that prey item and they'll actually use their own little octopus drill. This is called the salivary papilla. So if they can't crack open that shell, what they'll do is they'll actually drill a hole. So they drill a hole with this octopus drill right here. Once they drill that tiny hole, they actually pass saliva through that hole. And that saliva has enzymes that help break down the crab meat or tissue. And it also has toxins. And these toxins will actually paralyze the animal. And so it will paralyze the animal. And so basically, if it is a bivalve, as you can see here, that bivalve kind of gets scooped up, drill a hole, you can then send that saliva in there. It paralyzes the animal, so the animal can't use its muscles to keep the shells closed. Falls open, and that octopus can scoop that food out of the bivalve. And so this was kind of a side project that I did, seeing if octopuses drilled in certain prey items, so depending on shell thickness for bivalves, and depending on if they had a trap door on their foot called an operculum in gastropods. And when I saw that in shells that were thin, there was no drill hole. However, because they were probably able to pull it apart, however, there was drill holes in animals or bivalves with thick shells. So as you can see that here, here's a drill hole on the side. And if you look down here, if you turn the bivalve over, kind of where I shaded in gray, that's actually the site of muscle attachment for the bivalve. So the octopus has strategy. It learns where to drill, so that drills directly into that muscle of the bivalve and then injects that venom, that toxin. So then so the bivalve opens up. So the octopus has some strategy behind that. Then what we see in the gastropod is that there was no drill hole if there was no operculum. However, there was a drill hole if there was an operculum, like in this conch right here. And again, there's strategy behind that. The octopus learns where it's more efficient to drill this site of muscle attachment, and you have that drill hole right there. All right, and so getting more into looking at the different behaviors, the beauty, and of course, the brains of the octopus. And so behind finding all these different types of food is the behaviors. So you can see here, if you watch the octopus, has different behaviors and strategies to find this. It will actually stick its arms down into the holes. That's called a grope searching behavior. It'll expand its web. You can see right here, it actually sits for a second. So that's really important to bring up later. After it's done sitting, it does what's called a parachute attack. And then again, another parachute attack on hard bottom or on structure. And so bringing up the senses again, and what's so important about how the octopus senses its environment, you have again that really sharp image forming eye that is not only looking for predators or habitats, it's also looking for potential prey areas to search for food. It has that orientation, making sure that it can get from point A to point B. Octopuses have spatial memory, so if they need to beeline back to their den, they can do this when they're out foraging. We already talked about the taste, and so octopuses, they are sensing their environment, when they're out finding food, and of course, that touch and taste that I just described. So I already went through this in detail, explaining the octopus behavior. What I really want to talk about now is not only is the octopus sensing its environment because it has to search for prey or it has to search for a habitat, but when it's out and about, it also has to camouflage. And that's the beauty behind the octopus. All these beautiful colors and what we call smart skin. And so the top layer of the octopus, the skin in the epidermis, we have these color changing cells called chromatophores, and that you might have heard of before. And so these chromatophores, or these cells, are filled with pigments. So they're filled with colors that can be orange, brown, red, and yellow. And they're under neuromuscular control. So the brain tells the muscles to either expand to show the color or to relax to not show that color as much. So when you see this, a lot of one color, maybe a stripe across it, that's the octopus's brain telling the muscles, hey, chromatophores, you need to expand a certain way or contract a different way. So you get these different color patterns of the orange, browns, and yellows and reds. But as you saw, octopuses have a rainbow of colors going on. And so there's other color changing cells or reflective cells that live under the chromatophores in the dermis of the skin. So you have iridophores and leucophores. And what those other cells do is that they can reflect light. So that's where you get your blues, pinks, yellows, and greens, or you can reflect white light and you can have white spots along the octopus. So not only does the octopus have to sense the environment, it has to camouflage as well. And so taking in all this information means that the octopus has a really big brain. And so the octopus has about 500 million neurons. And that's almost as many neurons as a dog or a cat. And so you can see here, this is the octopus brain, the central brain located between the two octopus eyes right here. And so if you blow it up and you look right here, you have the central brain. So remember, I said the octopus has 500 million neurons. The central brain only has 50 million neurons. each optic lobe actually has more than the central brain. You have 65 million neurons in each optic lobe, which shows you how important vision is for this octopus, and what I've been touching on throughout the presentation. But this is also the lobe that helps with visual learning and memory. And so this is very important in the octopus's life. So you can see living on the bottom, this benthic animal. And so that still only makes up a small portion of the neurons or the brain cells for the octopus. It has 300 million neurons distributed throughout the arms, which shows you why I was kind of hitting on how these arms do so much information. They have to gather and store and figure out all this information. And so what we have here is showing the octopus has the central brain between the eyes, but actually it has a nerve ring. So you have kind of a nerve cord going down each arm, but then a nerve ring around the arms. And what this means is that the arms can do certain tasks without talking to the central brain. And this is very important because they are interacting, directly with the environment, and they have to figure out what the next move is, and they have to do it quickly. So that's pretty cool to think about, the distribution of neurons for different animals. And so just to sum this up really quick, we have all this information about how octopuses use different resources. For these two animals, they're underwater neighbors. However, they have different tactics, and we see that they have different homes. The common octopus living in a rocky rubble home, the Atlantic longarm living in a sandy home. And then they eat different things, and also they feed at different times of the day, so they are avoiding each other. However, the octopus monitoring gadget also told more information about the story about an octopus living underwater and the different encounters that it has. And so octopuses have many predators, as you can see here from above. We've got a diving marine bird or cramp cormorant that's trying to snag the octopus. The octopus isn't having it. So depending on the potential predators, that could also change when the octopus is active. Here we have an octopus returning to its home, and I like to see that quick camouflage. So not only can the octopuses change color, they can also change skin texture. They can raise their skin up into bumps or even like fleshy tabs. You can see here, I mentioned before that dramatic display. We have a potential predator, the mutton snapper, and the octopus turns big in that pale white. You see it again here in the Atlantic longarm. There's that stingray that swings by. The octopus tries to get really big and scary when that predator comes around. And then next we have an octopus leaving during the nighttime and a purple mouth eel coming by. So we see that the octopus has predators from above, it's got predators in the water column, and also it has predators on the bottom, this being the eel. And so you see that the octopus slowly creeps back. And you can see soon here that the eel's head will pop out, waiting for a tasty treat. Eels are known to specialize on octopus, and the octopus probably knows that. You can see it's creeping back really slow. Thinks about it for a little bit. And then says, nope, I'm out of here. Decides to find a new home. So octopuses, could change their behavior because of predators. And also, usually octopuses do not run into each other, but we have these high abundances of the two species at Blue Heron Bridge. And you see that they're running into each other, they're doing fights, they're doing den takeovers. And so there starts to be more interaction within the two species and also between the two species during the times that they're most abundant there, so during the springtime. And so then you start to think about it might have not been important before for a solitary animal to have chemotactile cues. However, octopus communication becomes really important in high abundances, and it may be very important for these two species to coexist, which brings me to the octopus handshake. Remember that I said chemotactile cues, they're definitely sensing with their hands. And so octopuses know, they can visually see that there's another octopus nearby, but scientists think that they can't tell if it's the same species or if it's the same or opposite sex unless they do an octopus handshake. So here you have a common octopus in the back, and you have that Atlantic longarm standing up really, really tall. This is that blue heron. You see them reach out to do their quick octopus handshake. And it doesn't take long. They do that quick handshake. Remember all of those chemoreceptors on the suckers, and they say, whoa, nope, you're a different species of octopus. I don't want anything to do with you. So that communication may also help these two species to avoid each other when they're living so close. And so all this information gathered from this research project that went on for about 4 years is now very important for future research projects. And so we have all of this video that I've looked at for camouflage tactics, for how they forage, how do they feed, and as you can see here. And so now this video is actually used for a new project that I'm working on in collaboration with an octopus lab at the Marine Biological Laboratory. So we're taking all this footage and we're actually looking at octopus arm behaviors. We're looking at what each arm does, how they move it, and the different deformations. So we think about if the arm elongates, shortens, if it twists, and so on, and if it bends. So many, basically an infinite number of bends in an octopus, because an octopus has no bones. They actually have many muscular hydrostats. So you can think of a muscular hydrostat being your tongue or an elephant trunk. And so why it's important to study these animals, and you can apply them to different areas like soft robotics. So we're applying this information that we're studying from animal behavior, specifically the octopus, and applying it to the biomimetics, the biorobotics fields. So that's one project that's ongoing. Another project that's about to start up is looking at the octopus microbiome. So what bacteria are living on octopus skin? And this project is ramping up because it's almost octopus season, starting in March. And so octopuses are really important because they're important to many marine food webs. They're right in the middle. They graze on those benthic animals like we saw on their prey, but they know they are prey items to many apex predators, like we saw the birds, marine mammals, large fish. And so it's important to make sure that we study, suitable habitats and make sure that octopuses stay healthy. So we're trying to figure out what keeps an octopus healthy from harmful bacteria. And it's been shown that bacteria, they can play a key role in an octopus's, not just octopus, but cephalopod lifestyles. And so examples of this are the relationship between a bacteria and the bobtail squid. And the bobtail squid, it looks like it's glowing because it has a light organ. Inside that light organ lives these bioluminescent bacteria. And so there's this relationship between the bacteria and the squid. And it's very important for both, and very important for the squid because it helps protect this animal from predators, because it helps it camouflage. Another relationship, another animal that you may be very familiar with is the blue-ringed octopus, a very, very toxic, probably one of the most venomous marine animals out there because of its toxin called tetrodotoxin. And that toxin is actually produced by a bacteria that lives in the salivary gland, or like the saliva pouch of this animal. So again, another very important bacteria and octopus relationship. And so what I'll be doing next in come March, very soon, is looking at the bacteria that live on octopus skin. So I'll be swabbing what I call octopus bellies, or I'll be swabbing the mantle area of the skin for this animals. And I'm just showing you the diagram of the small research vessel, OctoGirl. So what this is it's pretty much a dive float or a boogie board that will hold my sampling equipment. So the sterile swabs, you can think of them as Q-tips. And so I'm not able to swab an octopus underwater. So what I'll be doing is carefully handling the octopus, bringing them up to this octopus holding bin that actually has holes in it. So seawater will be able to get in. So the octopus will still be in the seawater. What I'll do is I'll just lift the mantle up. I'll do a quick swab, and then I will cap that swab, put it back in one of my containers. After that's done, I'll then pick up the octopus in the bin and then put it back in its den. And so I wanted to make sure that the community knows about this, so when they see me out in the field using this, they know that this is for research. And I also have the correct permits to temporarily collect the octopus and do this for research. And I'm doing no harm to the animal. And so that is an overview of species of octopus you can find in Florida, how to find octopus in Florida, their habitat, the times that they come out, and when they're here at Blue Heron Bridge, and what I'm currently up to, my research projects that I have going on. You can follow me on social media, Facebook, Instagram. I'm updating all the time on cool octopus facts, and also I'm doing research updates as well. I think we have time probably for questions, but if I don't get to yours, please message me on one of those social media pages, or you can contact me and my FAU email right here, cbennis@fau.edu.
Okay, awesome job. Thank you, OctoGirl. Well, guys, we're really sorry about the audio in the beginning of the presentation, but we were able to figure that out. So, yeah, sorry, Chelsea.
Oh, no.
You're good. But we do have a couple of questions. Not everyone's questions are going to be answered. We'll have Chelsea get back on here and she'll answer you personally, because some of them are a little more, time consuming. But just really quick, Chelsea, we're talking about cold weather, and somebody asked the question, are there cold water octopuses? And I actually looked it up when you were talking, and it says that there are some that live in the Arctic and Antarctic, but they're very rare. Do you know how the Blue Heron Bridge octopus fare when it's cold, when the water temperature changes?
Yeah, so usually octopuses have a short range of temperatures that they can survive in, and that can change throughout their life. So usually I see juvenile octopuses at Blue Heron Bridge during the springtime because water temperatures are warm. And so they like those warm temperatures to grow super fast. However, to slow their growth rate, their metabolism, they'll actually move to colder waters, deeper waters, offshore. And so it's also been shown that sometimes it also gets too warm in Florida for those adult octopuses, and that's why they move to deeper waters. And so if it gets too cold, I haven't really studied the temperature range in the species at Blue Heron Bridge, but I do know that they do migrate depending on the temperatures.
Awesome. I also had another question. Are the lifespans of both the Blue Heron Bridge species the same?
They are relatively the same. All octopuses are short-lived. A lot of them only live 1 to 2 years. And that's about the lifespan for both the Atlantic longarm, the common octopus, and many of the Caribbean reef octopus. Just to give you an idea of how short they are, another cold species, not as cold as the ones you mentioned, but a cold water species living, on California, the giant Pacific octopus. So that's the largest octopus known, about 300 pounds, about 16 feet. And so that large animal only lives for about 5 years.
All right. So another question is, how do you tell the sex of an octopus? And do they have a gestation time? How often do they breed? And why are they gathering between March, April, and May at the bridge? We know that they have eggs, but
here we go. Lots of questions. Yes. Here we go. So yeah, so for only like the blanket octopus and the paper nautilus, they have that sexual dimorphism. So the males are really the dwarf males, and then the really large females. So those are easy. But for the two species that I study at the bridge, you have to look at their third right arm. And so it's the third arm for all males, and it's either the left or the right arm. Third arm for depending on the species. So if you look at the third arm, you have to turn it over and you see if it has a groove in it. So the male octopus uses its third arm, I call it the sexy arm, to pass that packet of sperm to the female, so into her mantle. So usually the males will have a groove, or they will have enlarged suckers, or they will have more suckers on that third arm, depending on the species. So you got to look at that arm to figure out if it's modified or not. If it is, a male. If it's not, female. Unless you see them mating. Sometimes you'll see them mating and you'll see the male kind of reach and extend his third arm into the female. And then you can kind of gauge which one's the male, which one's the female. So
disclaimer though, we don't want people picking up octopus at the bridge. So
yeah,
y'all are just gonna have to just
sometimes
use your imagination.
Yeah, and that's why it's good just to, if you see them mating, then you can usually gauge, or sometimes you can actually see, if it's a larger animal, you can see the sperm packet pass down or into the mantle. So you don't necessarily have to pick it up, but yeah, just observe with your eyes. And so after that, females, depending on species, can lay thousands to 100,000 eggs. Depending on water temperature. Of course, warmer water temperature, gestation period is less, can be 1 to 3 months. And so after that, there's no parental care. So the mom usually does care for the eggs, will either, for like the common octopus, will attach them to a hard substrate, will aerate them, blow water over them through the siphon to make sure they stay clean, they're oxygenated. But after the babies hatch, they're on their own. Let's see, and
usually die, right?
Yeah, so since the males and females do die usually after that mating, they mate with multiple males and multiple females, but usually towards the end of their life. So it's not just the females die after they give birth, but also the males, because they're just at the end of their life expectancy.
And actually, there was a great documentary on Netflix, My Octopus Teacher, or was it on, maybe it was on Disney. I can't remember which stream it was. But if you guys wanted to learn a little bit more about the life cycle of an octopus, that's a cool documentary to check out. So another question, Chelsea, for you really quick, and then we're going to go ahead and wrap it up. The octopus at the Blue Heron Bridge, people want to know, are they being collected? Are they being hunted by the divers or spearfishing people?
They are not. So the Blue Heron Bridge, just recently, a few years ago, it was termed a marine protected area. So you cannot collect animals from the Blue Heron Bridge. I had to get a special permit just to temporarily collect them for research. And that is the only reason I'm able to collect them and then release them back into the wild. So no collection at Blue Heron Bridge.
Awesome. Okay, so I'm going to go ahead and hide this slide, and I'm going to bring into the stream here. If you guys want to follow what Chelsea's doing, she has both a Facebook and an Instagram page, OctoGirl, and you can look there at some of her videos and her photos and see what's going on. And she has really cool like Facebook and Instagram stories, so make sure you're following her stories as well. she's always giving great presentations about all types of topics of octopus. So make sure you're keeping an eye out there. Another thing too is we have our raffle. So if you registered for tonight, you are going to get in the raffle for, we have actually 2 things we're raffling off, right, Chelsea? The first thing is we have an OctoGirl swag bag. And in her swag bag, she has, there it is, that's the OctoGirl logo. And in the swag bag, there is the OctoGirl charm bracelet and the OctoGirl.
There it is.
There you go.
Right.
And
we've got a few stickers, the OctoGirl sticker.
Awesome.
I'm also a scientific writer for OctoNation, so if you don't follow OctoNation, give them a follow. We have a new website, so I create all the octopus profiles and science and education content. Got some OctoNation stickers and magnets, actually. The OctoGirl Force E cup.
And so if you don't win tonight and you like some of these things, we do sell them overseas. So make sure you come into the stores or look at our online. And an Octo photo print. Awesome.
It looks better in person.
All right, so should we see who the big winner is? All right, everybody see, I've got my random name picker up, and I'm gonna put everybody's name in here that registered, and here we go. The big winner is Emily Coe. Emily, you're our big winner for our OctoGirl swag bag. If you're listening, give us a thumbs up. Woohoo! All right, so another thing, Chelsea, that we're going to raffle off tonight, okay, is we are going to go ahead and try a dive led by an OctoGirl and a 4C professional. So we're going to do octopus dive guides at the bridge. So it's something that we might start. So we're going to try it out with the winner of tonight and see how it goes. And you can go along with Chelsea and watch her do her research. She'll give you some more information about octopus. And you'll also have a 4C dive guide there to monitor the dive and make sure everyone stays safe. So when you win, we'll reach out to you and figure out a good time and date that it works for you. We obviously have to go on the bridge's tide times. So let's see who the winner is of the Octopus Dive Guide with Chelsea and 4C. Artie Bloom, you are the big winner tonight for the dive guide at the bridge with the OctoGirl. I'm not sure Artie's going to want to do this one, but we'll see.
Uh-oh.
He usually likes to go offshore.
Let's change his mind.
Let's change his mind. So Artie, give us a thumbs up if you're listening. All right. So again, guys, thank you all for watching. We definitely appreciate the support. And also, Chelsea, what a fantastic presentation. We appreciate you coming out and giving your time and the research that you're doing to keep our octopus, happy and healthy and doing ocean conservation. So it's fantastic. And we love you, and everybody else loves it. So everybody, thank you so much.
Thank you. If you see me at the bridge, say hi.
And have a great rest of the evening. Bye, everyone.